Hello, and welcome to marspod, the podcast about how AI is changing society and the big picture impact it can have on your daily life. Today's episode is brought to you by MarsCrowd, your one-stop data labeling and collection company providing real-life data to boost your machine learning models. I'm your host, Mark Wesley, and today's guest is John Ball. John Ball is the CTO and co-founder of Patom. He has been studying how to emulate brains since his first sight of computers on Star Trek back in the 1960s as a child. Imagine someone who dreamed of being Scotty, not Captain Kirk. In 2016, along with CEO Beth Carey, they launched their Palo Alto-based company. At the San Francisco launch, their poster read, "Call Beth, no, John," as an easy way to show that there is more to language than word sequence, since that would mean call Beth. You can even try it with your favorite app today. John, welcome to the podcast.
Thank you, Mark. It's a pleasure to be here today.
Yeah, it's great to have you on. Like we said, Pat Inc. is in AI and specializing in natural language understanding. Could you kind of introduce Pat Inc. a little bit to us before we get going and kind of the general overview of the company?
Sure. Yeah, that's a good place to start. So we were looking for a name for Pat back in 2016 when we launched in San Francisco, and I'd always been focused on what it is that makes brains different from today's AI. I'm pretty old now, so today's AI was quite different when I was working on it in the 80s to today. But the thing that struck me was that brains are unbelievably fast. So when we're having this conversation, I'm using all of these words at this unbelievably fast pace. Mm-hmm. You're understanding what I'm saying. And yet supercomputers can't do this, and they still can't do it today. So the question is, what's fundamentally different about our brains to computers? And to cut a long story short, the theory that I came up with was called Patom Theory, so for pattern atoms. And the idea is that in the brain, when we recognize anything, whether it's a word or a person, we're activating this atom, this pattern representation of that person that's extremely rich. And as a result of that, the brain is very rapidly taking this massive amount of information, finding the key things that relate to this environment, and then it's able to use it. So with a very simple paradigm, pattern atoms then explain what a brain's doing. So what Pat Inc. is doing is it's taking that idea of pattern atoms, of patterns. We then stolen the beginning, which is Pat, to create the name. And then we focus on how we can provide language services to today's industry. There's a lot of discussion about how AI today is so amazing because you can have chatbot technology that's doing things that are quite human-like. But to take it to the next step from what we have today, you can say to Alexa, what's the weather today in San Francisco, and it'll give you an answer. But if you say, what's the weather like today in San Francisco and New York, it'll probably just give you the San Francisco answer. So that next level of expertise that we're going to see from the next generation of AI and chatbots is what you need Pat for. And that's pretty much our pitch to the industry in general. It's the next generation of chatbots that will revolutionize how we work with machines, with either voice or with text.
Mm-hmm. I think that is really a fascinating subject, and I think we're going to have quite a good conversation about that. But one thing that we like to do in the beginning, before we get into the details, is a couple little things. One is AI Doomsday Theory. So do you think Alexa and Siri are going to be taking over the world sometime in the future? What is your prediction for the AI Doomsday?
Yeah, look, I think we're actually living in the AI doomsday scenario today, which is that we think that we're close to having AI, and we're putting billions and billions of dollars into developing this technology that's just not making the grade. Alexa can't take over because it requires programmers to set up these sample phrases that the system matches, and then programmers have to write what to do after that. So it's not intelligent in that it's understanding what you're saying, and then it's producing responses as a result of it. So the next generation has to take not only the words, but what the meaning of those words are, and then applying it in some way, and somehow learning the meanings and the interactions, so that the next time it can generalize from that type of experience. And the machine learning systems of today aren't doing anything like that.
I see. Okay.
And so that's my doomsday scenario. It's not as exciting as Terminator, but
exactly, or the things that Elon Musk is saying about, how we're already too late and things like that. But let's get into the origins of Pat Inc. and kind of go back to what your educational background is, and kind of what started this all, like at the beginning.
Great. From my perspective, when I was about 2 years old, I developed a fascination with language. It goes back that far. And partly
the very beginning.
Yeah, that's the very beginning. But my father was an educational psychologist. He was the one that did the early Sesame Street work, and he worked at Columbia University in educational psychology. So it turns out he did a lot of experiments on me. And one of them was, for example, a PhD student had said that children under the age of 3 can't do squares, they can only do circles, that type of thing. So my father would come home, he'd say, draw a square, I'd draw a square, and the guy would get an F for his PhD thesis. that type of thing. But I remember it, when I was about 2, I was in our place in New York, and I was thinking, I want to list all the words I know. And I started listing them, and then I'm listing, the verbs and the joining words, and I realized I can't do it. I know far too many words to ever recall them, and I was just fascinated by what it was that helped me understand language. So that's my earliest memories of it.
Okay. And then I know that you have a cognitive science background. So kind of like when you were going into, early, or I would say undergraduate education or something like that, what was the educational background and path that set you up to be able to eventually found or co-found Patom Theory or Pat Inc.?
Right. When I went to university, we'd moved to Sydney, Australia by that point, which explains my funny accent these days. And I was a scientist, so I'm always been really keen to be a programmer. I want to emulate Scotty, my idol from Star Trek, and so with mathematics and physics and the like. You're doing a lot of mathematically based things, and my lecturer in computer science said that we're never going to understand the human brain. That was her specialty. And I thought, well, that can't be right. And for the first time in my life, I really set aside the time to solve that problem and prove her wrong. And I'm still trying to prove it. So, I'm pretty dedicated to a problem like that. But the interesting thing was I spent the entire summer at the university library. I read books on neuroscience and linguistics and philosophy and psychology, trying to work out how this unbelievably slow brain can be doing more than a supercomputer. And the work that I'd read that said, well, a brain is just like a parallel processing engine, I thought, okay, well, that would explain the performance. But then when you try and do things with parallel processing, mathematics or other types of problems, it really is impossible to write the program for it because things are too sequential. So I came up with Patom Theory, and the idea is that if you went to a football stadium and there's 50,000 people there and you want to find somebody, how today's computers would work is they would ask everybody for their name. They then sort everybody based on last name or something, and then you can have a very efficient algorithm to find the person that you want. But then if you wanted to find out who was the youngest person, you'd have to resort them. And if you wanted to find, a person whose first name was closest to the letter L or something, you'd have to resort again. So today's computers have this terrible mechanism to go and find what you want. And a better solution would be to get on the loudspeaker and say, can, a person that's driving a red Corolla come to the middle of the stadium, and you might get 3 people, and now your shortlist is such that you can validate which is which. So that's pretty much the principle for Patom Theory that we've implemented, which is extremely fast because we do this non-index search, and we sort of cheat because when you get to the detail, rather than having people in this audience with their own data, we simply connect their names directly. So everything's done through this linking mechanism. So that's how I'd explain Patom Theory to somebody just trying to understand the difference between a digital computer and this new approach.
I see. So at the time there was a little bit of a time lapse, right, between when you kind of graduated from university, you got master's degree and all of that, to when when deep learning came out. Is that correct?
That's right. So I did my university through till about 1990. Deep learning became very popular about 2012 when Jeff Hinton's group was able to show an improvement over the image recognition. And I don't remember the number, maybe it was 20% improvement with that type of automation. And that was the deep learning explosion that we saw. And I guess the interesting part is that although that was nearly a decade ago, we've seen great improvements in some aspects of machine learning applications. But in terms of language, I don't think the average person would think that there's been any innovations whatsoever. Maybe we see chatbots, maybe we see Alexa, so the interaction with voice and the interaction with text is maybe a bit better. But we're a long way away from saying to Alexa, what's my weather forecast today based on where I'm going, and have it be able to understand that, know where you're going, then get the weather forecasts and tell you in such a way that it's natural.
I see. Yeah. So what do you think the landscape looks like for, companies utilizing NLP or NLU to kind of create these conversational AIs?
I get the impression that we're struggling. So the return on investment just isn't there for people that are putting the large dollars in that are necessary to get these applications up. I've seen numbers that to get a single intent working can be like $5 million for a big corporate company. And that doesn't stop the fact that a lot of these are multinationals that serve multiple markets, so they have to do their English one and their French one and their German one and their Russian one. And so all of that extra work is prohibitively expensive. And then once you've built those systems, you then have this maintenance problem. And we met with a guy who was an expert in the field and also from Sydney. We happened to be overseas at the time, and we ran into the Sydney guy that just happened to be doing deep learning implementations. And he said the problem they've got is they couldn't test the system. So they'd load all this data into the system, and then they could use it. But there was no way to validate in advance that the system was going to do what they thought after they made changes. I think that the applications for machine learning and deep learning are unbelievably strong at what they're good at. So, you go to the Amazon website and you want to buy a book, it'll tell you, hey, other people buy these things. And that's not a human level skill. That's a supercomputer skill where it's comparing all of the other people that have shopped and what they bought in conjunction with that. And often you get great ideas from it. So that's the powerhouse of it. The things that it's not as good at are the things like vision and certainly NLP, NLU, where it's trying to understand what somebody's saying in a conversation. And there's just not the natural conversations that people are expecting. You can go back to Star Trek from the 60s, and those machines understood these very complex requests.
It's interesting kind of just how like the amount of processing and the kind of data that needs to be fed into machine learning models in order to get them to be able to have the same type of synapses that we do when we're understanding and processing language. What are your,
certainly I'd like to come back to that thought, because the idea that brain synapses are intricately linked with knowledge, that's another point which Patom Theory has a different perspective on. So when I think of a brain, I think of a machine that is extremely precise. In this conversation that we're having, all of these words are generating ideas for you. I think you're getting the same ideas that I'm specifying. Maybe I'll speak on something quite abstract and you won't be able to follow that. But almost everything I'm saying, you're going to have a good confidence that what I'm saying is what you think I'm saying. And if you compare that to what a deep learning system's doing, it's got a very different paradigm where a programmer is going to decide what they think somebody might like to say, and then they'll think of, say, 100 ways of saying that, and then they'll write some code to deal with that. So that sort of pattern matching is very unnatural, and it's very restrictive because the numbers of things I might say could have tens of thousands of branches. The epiphany that I had was in 2011 when I was working with Princeton University. There was a group there called the WordNet Group, and it was looking at how the meaning of English words in a dictionary would combine. And my sister said to me, "Hey, why don't you just come to a coffee with me?" And she took me to a bookstore that sold coffee. And amazingly enough, I found this book there that revolutionized my understanding of how language works. I've got the follow-on book here. I don't know if you can make that out, but that's called Exploring the Syntax-Semantics Interface by Robert D. Van Velen Jr. And Van, who I now know, it was one of his students that had written a book on how language works. And when I opened it, it talked about the difference between dancing, which is this activity that just takes place over an indeterminate period of time, versus, say, breaking an arm, which takes a defined period to heal. And it was explaining how meaning works in language. So imagine that.
Interesting.
I've studied this thing for a long time, and here's a book that explains most of the answers of what I'd been searching for. I thought it was going to take me 30 years to research, and here's the book. And so I've spoken to Professor Van Velen, who now works with me, and we've been able to implement his theories on a computer.
That seems kind of like a match made in heaven, to be able to, be able to bypass a lot of the research that you thought you were going to have to do. Where were what was that initial kind of relationship like in terms of like how your background in cognitive science and what you had already been working on kind of meshing with the things that he was saying?
Well, amazingly, with all of the expert guidance that I'd had from university, linguistics was seen as this syntactic problem. So you have to work out, this word is a noun, this word is a verb. Then I've got these sequences. You have rules that produce a parse tree or something. That was the linguistics that was taught to me. And the idea was that you would forget the next step, which is integrating meaning and context. You'd leave that until a later step. And the problem that we'd had, in fact, right up to the present, is nobody's ever been able to produce a parser that recognizes a sentence, breaking it down by parts of speech. So think of it. We've gone to the moon and back. We've spent billions of dollars on the technologies needed to build spacesuits and rockets and all of the things that made that happen. But it was successful. And yet we spent maybe not a comparable amount, an absolutely large fortune to do the same thing with NLP. And we haven't got anywhere near it. I mean, you can't go to Alexa and ask it a general question. In fact, I find that Alexa only works if I go and read the cards and very accurately transcribe what the card tells me I can say to get the right answer. I'm not sure I've just answered your question then, Mark, so you might need to bring me back on track.
I think it was partially answered. The other part is like when you first started working with Robert D. Van Velen, what was that like in terms of the research that he had done and all of the research that you had done kind of meshing together? Yeah,
So what I could do is I could take the patterns of the language. So we can call them nouns and verbs, but predicates and reference, the things in the world and their interactions, the relationships. I could take any string from English and then convert it into a recognized sequence, into a sentence. And what Van had done as a syntactician was he'd looked at not only English, but he'd looked at Lakota, the Sioux Indian tribe in the United States. He'd looked at all of these diverse languages, and he'd come up with the explanations for the meaning of those sentences across the world. And it's just an amazing opportunity to say, well, if it means that in English and it means this in Lakota, and that's how you put it together, and there's these general principles, then why don't we just exploit that? Amazingly, we're the first company to grab the bull by the horns and start to exploit it because it's extremely powerful. One of the things that we did in the lab was we took 9 different languages that are extremely diverse. We took obviously English because that's the only language I speak, as well as my accent allows me to. And then we tried some French, we did Korean, we did Japanese, we did Mandarin, Spanish, Portuguese. We've had different people that are native speakers in those languages help us. And we found that we can take a meaning representation for all of the languages and then generate into those target languages with high accuracy. We can also match those languages into the meaning with high accuracy. So there's this amazing opportunity to take the chatbot model, which today is language by language, and convert it into a language-specific front end to generate meaning, manipulate meaning, say, to produce a response, to understand and decide what to say next, and then decide which language is the target language, maybe Spanish, and we push the answer out in Spanish. So we're having this interaction with, English in, Spanish out, or any type of combination. So it will vastly simplify all of our systems, particularly in the multinationals that have a need for multilingual support. So I think that's the main benefit we're getting from Van's work. I've got to stop. I've got to stop speaking with my hands.
No problem. Yeah, you're back in now. I think that's really interesting because I've studied Mandarin for several years now, and one of the things that seems to be really difficult to capture is some of the more artistic ways that language is used. Like, for example, Mandarin being very rich with idioms, these things called chengyu, which is like a 4-character phrase that is said, and sometimes the characters don't seem to have any relationship with each other, but there's a deeper meaning that almost takes like 2 or 3 sentences to explain in English. It's kind of interesting because even when I'm trying to learn Mandarin, it's almost impossible the first time that I come across a chengyu to have any idea of like what it could possibly mean. So is it possible, like with like kind of what you guys are working on, to kind of not just with Mandarin, but kind of capture maybe the artistic side of the language?
Are you pulling my leg? So,
I don't know.
There's an example. So what is it about pulling my leg that's unique to English that doesn't translate literally? And there's lots of examples like that. Our technique is to say we'll recognize words, we'll try and find phrases, and then we'll also look for specific kinds of combinations of literal phrases. So pulling my leg, when you do the analysis on it, because it's a common linguistic example of an idiom or of a specific type of phrase. It's obviously not the literal words that matter; it's the meaning behind those words. So I can pull your leg, but if you change the specific words to like tug your leg, it doesn't mean the same thing anymore. It's no longer the idiom. So there's some combination of meanings that make it all work. So for our system, that's the approach. We break the words down to their meanings, we break phrases down to their meanings, and then we see what actually goes together to make a cohesive sentence. And ultimately, context has to then come into play. If I'm talking about pulling a leg and it makes no sense in the metaphorical sense, then it must be a literal example, like I'm pulling my dog's leg because it's got, a burr in it or something.
Exactly. Okay. I understand. I was a little bit nervous for a second. I was like, I don't know. When you asked if I was pulling your leg, I was like, I didn't know. But anyways, like the idiom that I like to use for Chinese is like mama hu hu, which means horse, tiger, tiger. And it like that's the literal translation of those 4 characters.
Right.
But it literally just means like average or okay. Like if somebody like asks like how are you at something, you say mama hu, and it just like horse, tiger, tiger, but you're just saying I'm okay, right? Like I'm okay at it.
Right. Yeah, one of our colleagues is Dan Everett. He's a company advisor, and his expertise is in linguistics and also the Amazonian language. He lived with people in the Amazon for 30 years, and his view is anthropology is a key part of language. So the culture helps determine what you say, how you say it, and so the language is tightly integrated with the culture. So for those types of expressions, once you learn what they mean and how you use it, it's now something that lots of people can use. And if the whole community in that language use that expression, then that's good communication. And I would give you the example of any type of movie title or something. It's the same type of principle where if I say The Wizard of Oz, you'll get this idea of Dorothy and tornado and maybe hitting her head and having this adventure. And all of that comes from just a very short sequence of words. And it's easy enough to learn. You can as a child, you probably see the movie and hear the title, and for the rest of your life, you have this ability to manipulate things that happened in The Wizard of Oz. And all of it comes back to meaning. So if we can store that type of thing, the meaning of titles and things and what that means, then interact with it, we're a long way away from today's machine learning, where we're just trying to work out, well, these letters or these words tend to go together, so you might mean that, so I'm going to hit that intent.
Exactly. I mean, when I've looked at like some diagrams and things like that of NLP, it's all about matching meaning to words, right? And I think that is something that we can talk about, like, just briefly for the uninitiated, kind of how, like, if they start searching NLP on Google or something like that, they may come across letters like NLP, NLU, NLG. How do these acronyms or like kind of phrases kind of work together, and what are their differences?
Right. Well, I take the very early definitions of NLP. So natural language processing is about the interaction with natural language. And the idea is it's running on a machine, so you're processing it. And that's made up of two components. One is natural language understanding. So I understand what you say, I'm converting it into something as part of this process. And then natural language generation, if I want to produce an answer, I then generate that representation into words, and then I express them to you. So it's a pretty simple concept. It causes a lot of anguish in the community and the AI community, because it's a pretty big claim to claim understanding. You can see a short sentence and say, "Oh yeah, I understand, and I can give you this particular answer." But is that really what you meant? And today's systems are very black and white. I get this sequence of words. The closest thing in my inventory is this intent. Bang! I hit it. Here's your answer. And it's easy to show how that doesn't work, that system of NLU. But it is called NLU, and in fact, there's lots of online courses that say we're going to teach you language understanding, and then they talk about intent recognition and classification of word sequences and using big data in order to get there. And it's kind of frustrating for the people on the cognitive science side of the world who know that that's not understanding, and you're taking our buzzword and making it your own. And now we have to say, when I say NLU, I don't mean that sort of NLU. I mean the understanding kind. And it's,
now you have to clarify before you even get into your explanation. But yeah, I think, like, for me, the diagram that I saw was kind of related to what you had said earlier, which is like you see an arrow pointing from text to meaning, and like how you get from text to meaning is NLU, and then from meaning back to text again is natural language generation. Like, how do you have a meaning that you want to portray and then end up converting that back to text?
Exactly. Yes. And so it shouldn't be a complex concept. But marketing departments of big firms, they're trying to show breakthrough technology, and what better way than to take this idea that we haven't solved, say that we've solved it, and then just direct people to say, oh no, we use context, and the definition of context, for example, isn't what we know it means either. And so in the context of this discussion, we've been talking about a bunch of things, and I can refer in our discussion to what we've been talking about. That's what context is. But some people would say this transcript, if I add it to other transcripts, now that's a different context. And I think that's actually the definition of out of context. So we're starting to use the opposite words to what we mean. And
I think that reminds me, like, when I was, looking at the video that Patom put out, was being able to recall something from an earlier conversation and being able to kind of move forward with it without having to provide that context, like, before you start talking about it. Like, it was something like, at first, you're kind of chatting with the chatbot. You say, like, I want to book tickets for May 10th. Actually, no, I mean May 15th. And it's two separate line items where you say May 15th, but it is still able to understand the exact date that you want to go to. And then maybe a day or two later, you kind of recall that earlier conversation. Can you kind of explain, like, how Pat Inc. does that and how Patom Theory kind of works that out?
Yeah, the big thing that Patom Theory does is it allows you to access different pieces of context with only a couple of pointers. So, if we have this conversation now, and I can access it again simply by following a pointer to this conversation, then I've got immediate access as it relates to you. So I can think, oh, Mark, okay, here's this conversation. Here are another couple, and now I've got a useful way of interacting. So what we see of the next generation systems is when people start to build a relationship with their supplier, with their company, they're going to provide information like, who your sister is, your spouse, your family members. And then when you book something, you're going to be referencing those people. The next time you call to book maybe a similar trip, you could say, I want to book the same trip as last time. And the machine can go, oh, that was the one where you went to, say, Paris and back with your sister and your wife. And you can say, yes. And now you've got all of this information ready to be applied to this new problem. The system still has to work out, are there valid flights, and what are the hotels looking like, and will I get your rental car again? All of that stuff, if the machine can do it instead of the individual and display it on the screen, you can imagine how easy it is for a user to say, yeah, that's what I want. Yep, except no, I don't want that rental car. Can you upgrade it to a sports car or something? And so that's genuinely the next generation of conversational AI, where we're using the context that we develop with that user for their benefit.
I see. When you guys are building out conversational AI for enterprises and larger companies, what are some of the challenges that you face when like testing out the model or like the application itself?
Right. Well, it comes back to there's limitations in our technology today. So we don't have the full vocabulary. We don't know the general knowledge that normal people have, but we think people are contacting an enterprise in order to get a job done. And there's a system today that allows people to work with enterprises to get a job done, and that's called the internet. So if you look at how the internet works today, you'll go to a website, there'll be some menu items. You can click on a menu item like, I don't know, book a ticket, and it'll take you to another menu system, which will say, how many tickets do you want? When do you want to leave? Massive amount of information. And you as the user populate all of that for the system. And then once you're happy with what you can see on the screen, you'll click on pay, and it'll open another dialogue, and then you can put lots of information in, and then you click on that, and then it'll open another dialogue, which is the confirmation of what you want before you pay, and then you click on something. So that's the type of thing that we can emulate today with today's technology. And you can do it without having to have the type of conversation you and I are having now, which is adult level English interaction. You can simply ask a question like, how many people are going? And you can say 2. Is your sister going? No, my wife. That type of simple to and fro is a much better way of driving a conversation to achieve a goal. Now, what makes people interesting is that we have the ability to carry on multiple conversations at the same time. So we could be talking in one sentence about method of payment with my MasterCard, and then at the same time say, oh, and I'd like to pay today for the flights or whatever in 2 weeks' time. So all of that is very controllable as separate elements of one conversation. And we think once people start to see that in the real world, that's going to be just a much preferred way of interacting while we go and develop the full-on technology that would allow a human-like conversation to take place. But I see that human-like conversation still being a few years away.
Okay, so what are speech-to-text tools able to do right now, and how do you see that kind of progressing as we move forward?
Right. Well, the speech-to-text is probably the critical piece, to hit that Star Trek requirement of being able to interact with your machine. And today's speech-to-text is a good mathematical model which takes the sounds that you're making, looking for words that can match in that sequence, and then statistically slotting the words together to get a result. And you can see it on the TV if it's doing automatic captioning. It's not too bad. It gets errors, but it's not too bad at getting the words that were being said. Not good enough for proper interaction. And the other thing that's missing from that interaction is the emphasis. So when you're talking to somebody, you can use the emphasis of a particular word to completely change the meaning of that sentence, and you can't see it if you're only getting the written form. And one of the flexibilities in language is the myriad of ways that we can say exactly the same thing, but put emphasis on the different words. I'll give you an example. So if you said the man is tall, you're sort of saying, well, there's this concept of tall that applies to the man. But if I said it is the man that is tall, I'm unambiguously putting the focus on the man. And we have the ability just to keep playing around with those word sequences to be crystal clear about the point that I'm making. But normally you don't need to go to any efforts in language, because people just speak based on what they expect the other person to be understanding, and they tailor their speech with exquisite precision, I like to say, in order for that other person to know exactly what they mean, not too much, not too little, and vice versa.
Yeah.
So the emphasis is the piece that's missing.
Sorry, I was going to say, like, it's like if you want to say, like, did you want that or did you want that, right? Like, that part would be missing, right? Because of the intonation or the lack of understanding of intonation. Exactly.
And I remember you were talking before about your experience in learning Mandarin, and one of my friends, Chris Lonsdale, actually one of our investors as well, he's an expert in that type of neurolinguistic programming environment that goes on when you're learning language. That's his specialty. And he was explaining to me that in order to learn a language, one of the things is just to soak it in, to experience the sounds of that language, so that your brain automatically starts to go, these sounds go together. So it's before you're able to form words, you're getting the sounds right, and then you start to pick up words, and simply by saturating yourself in the language, your brain is doing what's necessary to start to pick up those patterns. And it's a hierarchy. If you don't recognize the bottom level sounds of the language, you can't recognize the words. And if you can't recognize the words, you can't recognize the phrases. You know, and that's why people have this terrible problem when they try and learn another language, because there's so much to learn. And if they don't get enough at one level, they can't take it to the next. It's probably not answering your other question, but I thought it was relevant.
No, definitely. But it also takes me back to, like, my first couple months in living in China, where, you know, going out to, like, a public restaurant or a cafe or something like that, the words are almost indiscernible they were for me. They were almost indiscernible to where I couldn't pick out a single piece, even if there was maybe a character or a word that I actually could have understood, because I wasn't ready at that base level to be able to decipher all of the different, like, tones and the different syllables that were going on.
Right.
But over the course of time, your ears are just training themselves to be able to kind of, separate every single syllable or every single word that's going on, to where you can basically just in real time say, I understood 70% of the words that were there, but there was still 30% I didn't understand, or something like that. So it's like you're aware of the words you know and the ones that you don't know. Then that really, I think, kind of that breakthrough for me, at least, kind of helped a lot, because then I'm starting to use contextual clues to understand the meaning of the sentence. And then you're able to fill in the gaps. And then those words that you didn't know, you run into them enough times, and based on the fact that you already understand what the sentence means, then you start to remember those words and understand their meaning as well.
Right, yes. Because I think a lot of linguists just marvel at how we're able to communicate with this amazing tool that we've got. It's a miracle.
It's true. It definitely feels like that. So I'm kind of curious, like, what is Pat Inc. working on currently? What's the project?
Our current the biggest project that we're working on outside of our developer tools for chatbots is a specific industry tool in the airline industry, where there's a lot of complexity around the scheduling of a complex trip. So if you want to go from probably the most complex trip would be, say, an around-the-world ticket, where there's a bunch of rules that airlines have around the order that you go around the world, what happens within a continent, what types of seats you're allowed to get access to. And there's this AI principle where you basically got this amazing, discrete, massive amount of data, and there's a path through it that gets you the thing that you want. And with a language interface, you should be able to get the information from that amazing amount of data, and then get the correct path through it. And so we're working with the travel industry to make that a reality. And the prototype's looking amazing, I've got to say, where the user doesn't have to say very much, and we can get right to the end of this very complex interaction. And unlike today's systems, where you would have to say, I'm taking off at this time and landing at that time, and then I'm going from that time in this place to this place at that time. It's pretty mind-bending for a person, because it's not how we think. You're thinking more, I want to go next week, I want to be away for a month. And then the details about you landed at an airport, you get a rental car, you're staying at a hotel, getting all of the dates right. It's very hard for a person, but very simple for a machine. So we're experimenting now with how to have very few interactions, but get a very complex itinerary together with all of the things the user wants, and the user can then just see what you've asked for, because multimodal is much more effective than voice for problems like this. And then the user can say, oh no, change London to Bristol, for example, and then you can see that change, the hotel booking changes, the car rental changes, and then how does this look? And the user can say yes or no. So that's an obvious next generation application for this type of conversational AI. Most of the work isn't in the conversation itself, it's in how you manipulate the modalities so that you get a good experience. But people are going to love it when we finally get to the end of this development cycle.
It's true, especially for your example with kind of changing from London to Bristol, we as humans have this expectation that when we change a key piece of information, the other details are also going to change. And so I think it's important to have kind of a technology that captures that rather than tries to keep everything else the same, but just change one detail.
Right, and the interesting part is that's not our expertise. Our expertise is in the NLP, NLU space, NLG space, as we talked about before. And there are companies that specialize in the reasoning engine requirements, so that you can take your knowledge, fit it to the data that's out there, and then get the right result, which we then manipulate with language.
Exactly. So I wanted to ask you, if somebody wanted to kind of learn more or do more research on Pat Inc., where would you recommend they go?
Around the technology that we've implemented, I've started writing Medium articles probably 4 or 5 years ago now. If you have a look at our website there, so I think it's called medium.com/Pat_Inc. We'll have to check that. But in fact, you probably find it if you search on the web. Medium, Patom.
Yeah, and we can also include a link in the description, so
great.
No problem there.
Yeah. So I've got a lot of articles. The more recent ones I'm looking at, one of the end goals of NLU, which is if you're taking a lot of a conversation or of a book or something, what it would look like to convert that into a meaning representation. Knowledge graph is the current term that people use to describe that repository. So the technical details about going from the language to the meaning repository for some type of permanent benefit, where you then build the meaning repository out and people in the future will have full access to that, so that information from books and speeches and knowledge is stored in the one place in a language independent format, so that if you're Russian growing up, you can have a look at the speeches of JFK in Russian, even though he spoke in English. That's the end result. The earlier ones, if you go back a year or two, I was very focused on parts of speech, because parts of speech with parsing was the reason why NLP systems didn't work well from their inception in the 1950s through till about 1990, when the world switched over to computational models and then into deep learning statistical models.
Yeah, and I remember one of the articles that I read of yours that I thought was fascinating. I believe it's called Rebooting AI with Common Sense.
Yes, Gary Marcus's critique.
Yeah, but you had kind of created an article based around that concept about how to introduce kind of Patom Theory to the equation, and I thought it was quite a good article. So I would also recommend that one.
Yeah, great, thank you. And I like the fact that Gary Marcus does a lot of work with the critique specifically on the machine learning, deep learning paradigm and the artificial intelligence requirements around the complexity of language and the like. Our main difference between Gary's work is that he's focused more on the end-to-end AI, and we're focused very narrowly on the NLP language understanding component. But I see mainly synergies in the types of things he's discussing, because at some point, it doesn't matter whether you're really good at solving the NLP part. We want to expand it to all of the other aspects of AI.
Yes, exactly. So yeah, I have a couple other questions just to ask you before we end our time here. But one is, like, for people who are interested in this field, or maybe in this discipline of AI, what book would you recommend somebody read to kind of further their, education?
I'd like to recommend the book that I showed you before, Robert Van Balen's book from 2005 that explains the syntax-semantics interface. It's a very complex book, though. It's quite difficult for entry-level university students to follow it. It's more of a postgraduate book. There's the book that I actually found in the bookshop, though, by Emma Pavey, and we'll put the name of that book in the details as well. But Emma's book is a much better introduction to languages globally. She covers sign language and different languages, meaning and so forth, in a far more accessible format to Van's book. And plus, my Medium articles. I've written quite a lot in the last 10 years that at least introduce topics. Maybe some of them too deep, some of them too narrow, but always.
I don't know. I mean, I don't know if I understood 100%, but for a marketing person like me who's not in the tech side, I would say that it's very clear and that you do a good job of explaining. So I would say that nobody has to be afraid of perusing the Medium articles.
Great.
Yeah, and then finally, what do you think is a misconception that a lot of people might have about AI that you'd kind of like to set the record straight on?
Yeah, look, the biggest one in terms of brain theory is that if you look at a neuron, it looks statistical. It either fires or it doesn't, and if it does, you then get these connections to other neurons, which, depending on how strong the connections are to the other neurons, it then forces those to fire or not. And that's people now have a very statistical view of that's what the brain's doing. And Patom Theory is the opposite of that model. We see the brain as being a very symbolic machine. So you either recognize or you don't. So I focus on the firing. If that neuron fires, it's like you've just matched a pattern. And so that's very precise. So I prefer people didn't just assume that a statistical system is the right way of modeling a brain, reasoning, and speech. It's probably better to just look at it as a very symbolic activity, very precise, and at least start with that. If you've got good reasons to say there's a part of it that's not symbolic, then great, but start with that. Don't start with the statistical one, because it just becomes very mythical, mysterious, and it shouldn't be.
Exactly.
And I've just been told that we're going to have a network interruption in 2 minutes, so
okay. Well, I think that this is a perfect point then to just kind of end the episode. But I just wanted to thank you once again for being on and for being willing to talk so much about Patom Theory, what's going on in the industry, and kind of clear up maybe some of the misunderstandings of natural language understanding and NLP. So thank you very much, John. I appreciate it.
Well, thanks very much, Mark. It's been a fun chat, and always happy to share my wisdom or lack thereof with an audience.
I would say wisdom, mostly wisdom.
Thank you, Mark.
Okay. All right. Take care, John.
Okay. Bye now.
Bye. That concludes today's episode. We want to thank you for listening all the way to the end. This episode was brought to you by MarsCrowd, your one-stop data labeling and collection service provider. For more info, feel free to click the website link in the description. We look forward to you tuning in for our next episode on how AI is changing society.